Hello everyone, my name is Ankith Uppunda and I'm here to present our paper, Adopting Coreference Resolution for Processing Violent Death Narratives. This is a joint work with my collaborators from computer science, sociology, and public health at UCLA. Let's start with the basic definition of coreference resolution. Coreference resolution is the task of identifying denotative phrases in text that refer to the same entity. We'll see an example of this later on. Currently, coreference resolution models are often trained and evaluated on OntoNotes, which is a large public corpus comprising of various genres of text. While the OntoNotes dataset covers a wide variety, it often fails with the granularity required for specialized datasets. For example, in the paper Towards Gender-Inclusive Coreference Resolution, the top coreference models struggle with gender-inclusive data. We saw this and we wanted to try applying coreference models to different domains. So we applied one of the current best CoRef models, the end-to-end CoRef model by Li et al. To violent death narratives from the NVDRS. The violent death narratives are very different in both structure and vocabulary to the current OntoNotes training set. We see the existing models fail to adapt to the specialized data due to the domain shift from general narratives to administrative data. The models also fail to adapt well to LGBT individuals. To determine how well the current model works with other domains, as seen in the previous slide, we look to the NVDRS. On first glance, we see about 5% of the victims are LGBT. These cases are especially important because LGBT youth are 5 times more likely to attempt suicide than heterosexual youth. In a time where public policy is being more and more influenced by the models and systems we build, it is increasingly important that we design these NLP systems carefully so that we can mitigate bias towards underrepresented groups. With this in mind, we present the violent death narratives, or VDN for short. As seen on the slide, we end up with 90 cases in our test set. The coreference annotations, we also end up with a set of coreference annotations that were produced by a team of 3 experienced coders under the guidance of senior public health experts. Sadly, we cannot release this data set to the public, so we performed separate experiments on GICOREF and MAP, 2 gender-inclusive and public datasets, to verify that our methodology works. Coreference resolution is often an important step for higher-level NLP tasks, so it is important for our predictions to be accurate. With a strong likelihood that it's being used for other tasks downstream, it is especially important that the model perform well on underrepresented groups. As seen in the misclassification below, we see how important gendered context is to the current performance in the model. Like we said earlier, VDN is administrative data that follows a rigid structure. In our experiments, we see 3 different cases that the existing model is struggling on. LGBT cases is one, usage of neopronouns or non-gendered pronouns is the second, and the last one is usage of non-gendered expressions, i.e. partner instead of girlfriend. In the example before, it checked out. In the example in the previous slide, it checked off 2 of the cases, LGBT cases and the use of a non-gendered expression. We see that on VDN, the overall F1 is fairly poor compared to how it does on OntoNotes. We see that E2E performs poorly on all subsets of the VDN as well. With this in mind, we seek to improve the performance, and luckily the data is very easily adaptable. We use Snorkel to identify key rules that could help bridge some of these domain gaps. We come up with simple rules such as switching to genders and stripping genders from pronouns and gendered words. As you can see in the example below, what happens when we apply these augmentations to an example passage. In this slide, we see the results of applying the rules that we introduced in the last slide. On the left, we see the performance of the entire data set, and on the right, we see the performance on only the 30 LGBT narratives. We see modest improvement with augmentation on the entire set, with a massive improvement from the baseline. However, the improvement significance is highlighted in the performance on the LGB narratives, as we see a big improvement, about 5%, from fine-tuned to fine-tuned with augmented rules. As we can see, the augmented rules helped quite a bit in its performance on the LGB narratives. Since we can't provide the data readily to everyone, we present the results on two datasets that are publicly accessible. GICOREF and MAP. Both are gender-inclusive datasets. GICOREF is a fully annotated coreference resolution dataset written by and about trans people, while MAP is a construction of binary classification examples taken from Wikipedia pages, with one pronoun and at least two people in it to choose from. On GICOREF, we see a substantial improvement on F1 and recall from our baseline models. Likewise, we see the difference in performance on neopronouns and binary pronouns substantially shrunk on the table below with our augmented model. As we can see, we are able to bridge the domain gaps in the GICOREF and MAP datasets with our augmented rules. In conclusion, we investigated the overall performance on the violent death narratives, which is data with a real social impact. And two, we showed how data programming can substantially improve the model's ability to work on underrepresented sets. It is important when dealing with real-world data that we make a conscious effort to try to mitigate the bias that we introduce to the model. Thank you.